Wait, where am I? There I am. Hi. Okay, let's talk about age structure diagrams. I love them. Okay, so an age structure diagram is basically a way of trying to represent the different age groups from the population over time. So here's how these things are set up. So we have a vertical axis that is going to show cohorts of the population basically in 5-year increments from 0 to 4, 5 to 9, 10 to 14, and so on. And where it tops out varies. Some will stop at 75 plus, some will go up to 100. But basically what we do is we'll put the males on one side, we'll put the females on the other side in case there's a difference between the two. There often is when we get to the older populations. Women tend to outlive men. In some cases, there's things like the one-child law in China that could make this a little bit different. And then the x-axis is either going to be the population, the actual population in millions or billions, or it could also be the percent of population that are in these different age brackets. What's important about these is they're going to let us predict future changes that are going to happen in this population. So as I said, we basically have the x-axis. I'm sorry, the y-axis is going to be in 5-year increments. I think I told you all this. You know what? I already told you all this. I'm going to go to the next one. Okay, let's unpack this a little bit. Okay, so here's what you really need to look at. What we're often interested in is the age groups that make up the pre-reproductive years. That basically is going to be people who are between 0 years of age and 14 years of age. Most people don't have babies in those ages, so we'll call this group the pre-reproductive. Most people stop having babies when they get to be about 45, so that's the reproductive years. And then above the age of 60, many people stop working, and I guess, they become, I don't want to say a burden on society, but they stop working, they stop contributing to the economy of their population. So the nice thing about this topic is it's going to let us sort of span the gap between environmental factors and economic factors, because those two are definitely in play with each other. All right. So basically, what we find is if we have a large population here, that means the population overall is going to end up growing. And if we have a small population here in the pre-reproductive years, we expect the population to decrease over time. So basically, we mostly use it to predict the future growth of a population. I think I told you basically everything here. Whoops, what just happened? Yeah, okay, yep, that's what I just told you guys. So let's take a look at Ethiopia. Okay, so Ethiopia has this sort of pyramid-shaped curve to it, and this is a classic look of a country or a population that is experiencing pretty rapid growth. And here's how we know. In this case, we have percentage of the population instead of actual population. So if we sum up 8 to 8, that's 16, 7 to 7, that's 14, and so on, we find is we got about 42% of the population is pre-reproductive. That's a big chunk. And they're not going to stay pre-reproductive. They're going to, in a few years, they're going to be the reproducing part of the population. So we find is if this part of the pyramid is large, then that means they're going to move upwards and start reproducing, and there's going to be even more behind them and so on. So let's think of it this way. If you want to really get a handle on it, let's look up here. Up here, what we've got here is about 4% of the population. Is that right? So a little bit over 4%. Let's say 5% of the population is in this range here, right at the top of their reproductive years. As they transition into their non-reproductive years, they're going to be replaced by this group of people. We got like 13% of the population. So what's going to happen is 4% of the population is going to stop making babies and be replaced by 13% of the population. They're going to start making babies. The population is going to get bigger. Hello. Now let's take a look at New Zealand. Now with New Zealand, what we see is, see how this is kind of flat at the bottom instead of spread out like the other one? This looks more like a column than it does look like a pyramid. In this case, what we find is if we count up this, we find there's about 21% of the population here. So about 21% of the population is pre-reproductive. Before it was like 43, okay? And what we have is about 42% of the population is in their reproductive years. So there's more people in their reproductive years than in their non-reproductive years. But wait, watch what happens. So right here, we have about 7% of the population. They are about to transition out of their reproductive years into their non-reproductive years. Who's going to replace them? Essentially, another 7% of the population is going to reproduce them. So the total number of reproducing members of the population doesn't change. This is a stable population. It's neither growing nor shrinking. It's going to stay whatever size it happens to be. Now, this graph doesn't tell us what the size of the population is going to be, at least when it's in a percentage. It just lets us know how much it's going to change. But look what can happen. Sometimes we get ones like in Japan and a lot of other developed countries where the bottom is smaller than the top. And what that means is there's been a change in people's reproductive habits. They have fewer babies now. Korea is like this. So we find us here now, we've got 14% of the population is pre-reproductive, and a significantly higher is in the reproductive years. So now look what happens here. All right. So here we have 7% of the population is going to transition into being non-reproductive, and they'll be replaced by a mere 5% of the population. So clearly that's going to make them shrink over time. All right. It's pretty simple to analyze these. Now, let's take a look at this. Maybe you're looking like, what's up there, Mr. Sampson? Well, it's pretty easy to explain in the case of this graph here. Okay, first of all, you can look at it, and I think the reason the makers chose it this way is it clearly illustrates the difference between male survivability at age and female survivability. Females just tend to live to be older than men do. And we find that across the board. We find that with the coronavirus deaths, there's more men than women, and so on. Now, if we look at this, what we see is this is a five-year span. This is 5 years. This is 5 years. But this is everywhere from 75 on up. So this is basically 25 years. So if we aggregate all 25 years worth of people up here, we see this big number of people. But now here's one thing to keep in mind. You don't always see this with every country. If you see this with a country like you do with Japan, which, by the way, has the longest life expectancy of any country on the planet, what this tells you is they must have really good life expectancy, which generally means they have good nutrition and good health care throughout the lives of the people. You know, most people have access to good health care and good nutrition. That's usually what we can infer from seeing a top that looks like this. Compare that to Ethiopia. Yeah, we're not seeing that so much there. What that tells us is they probably don't have access to good health care and to good nutrition. Now, we can compare these, and we see like we basically have 4 different shapes we look at, and this is going to play into a concept we're going to study in our next lesson called, or maybe the one after that, called demographic transition. But basically what you have is when you see countries like this, you have very rapid growth, and usually what this means is you have a country where there's a high fertility rate. People are having lots of babies, mostly because they don't expect them to survive. Now, as things get better and healthcare improves and nutrition improves, you start to see people having smaller children, smaller numbers of children, not lower birth rate. Okay, and as a consequence, this gets a little bit smaller. And then over time, what we find is it gets even smaller to where we have what we call a replacement birth rate of about two children per woman, 2.1 really. And then we end up with these ones here that are inverted, and that's because there's fewer babies being made than there are. Women are having less than 2 babies each, so the population is shrinking. Now, this one kind of looks like a coffin because if you think about it, that's not sustainable. I mean, there's never been a country that's stopped existing because of this, but it definitely is a new phenomenon just in the last few decades that we see countries transitioning into this, and that means their populations are shrinking. And it really would be a good idea for you to memorize these shapes because you're going to get tested on them in May. Now, we should be able to look at this and keep in mind this is a current view of it. This is not over time. Time is not part of this structure. Okay, this is just like take a snapshot, like take the census, publish the data, here's what you get. So from this, we could infer because we have more babies being born than people above them, then we can infer that this is a population that is on the increase. So in recent years, we probably see an exponential increase in the number of people in that country. Whereas if we look at one that has smaller size, straight sides, if the sides are straight, then remember that means that for every 10% of the population that leaves, 10% move in, so that the overall growth rate stays constant. So in recent years, we expect the population to have remained fairly constant. And many developed countries in the Western world are this way. But now we have a recent phenomenon, like in places like China, Greece, Korea. We have this situation we have a smaller cohort of pre-reproductive people than reproductive people, and as a result, the population is starting to go down. And now over time, this will modify itself. It's not like, people say, oh, Koreans are going to go extinct. They're not going to go extinct. But their numbers are going to definitely diminish. And usually this has to do with economic reasons and access to reproductive services. People get to choose how many children to have, so they have fewer for economic reasons. Now, this is a pretty amazing graph. I'd like you to just take a look at it. It just basically takes India and it lets you look over time at how that age structure diagram has changed. There's a lot going on here. So if you just look, we see the curve of their population from 1990 to projected to 2050. We can see that the rate of growth is slowing as this becomes more less pyramidal and more column shaped. But we haven't gotten to the point where it's starting to shrink. And so one thing we find is even though India is moving towards having a less pyramid-shaped age structure diagram, their population is going to continue to rise for a while because there are people who are still reproducing. And last thing I would say is I would strongly encourage you to just take a look at this video. It's a really good one of showing you how to think about these age structure diagrams in terms of healthcare and the changes in human populations. Bye.